Good afternoon, everyone, and welcome to the webinar, Scientific Minds Want to Know, Strategies for Addressing the Most Missed Areas in the GED Science Test. And today we have with me Susan Pittman. Susan, with us?
I am. Hello, everybody.
And we are so glad to see all of you with us. Today what we're going to talk about is we're going to talk about those most missed items that we're seeing on the GED test in the area of science, as well as some of the strategies and activities that there are out there to help us help our students overcome those challenges. And then finally, we're going to give you a few online resources that you can use in your classroom. But before we get started, one of the most asked questions that Susan and I have as we're doing workshops is, where do I find the materials? And so as we get started, let's just take a quick look. You should have gotten, when you signed up for this workshop, an email back saying, here are the materials that we'll be using, the PowerPoint and the workbook. But just in case, if you did not see those, all you have to do is go out to the web and go to the website, Florida IPDay. As you go out to this website, just click on GED and AHS, and then click on Webinars. In the Webinars section, you're going to see there Scientific Minds Want to Know, Strategies for Addressing Most Missed Questions. Under that link, you will see both the presentation slides and the handout that we're going to use. You will not see the webinar yet because, of course, we're recording it today. So you can download those for your use. But let's say that you missed out last week's webinar, or you say to yourself, gee, I'd like to listen to it once more. Again, same location, click on the social studies one, and there you'll notice that you have not only the handouts for the presentation and the handout of the workbook that we used, but if you click on the right-hand side, you'll notice that you do have the webinar that has been recorded. So listen away. So now that you know where the materials are, let's get started. Like we did last week, let's take a quick look, an update, so to speak, on where the stats are in Florida for science. And these stats were as of this last month, October 2014. And you'll notice that we're doing pretty well in science compared to math and, of course, social studies, with a 72% passing rate. In fact, what we're seeing in Florida is everything is slowly but surely going up, which is great news for all of us. In fact, Susan and I even like looking at that passing score of a 158. As we look at science, you'll notice that the average non-passing score, just like the other three areas, is really quite close. So we're looking at here again just 1 to 3 questions. If we can get our students there, bottom line is they will be in that passing range, and that's great news for all of us.
Bonnie, just a quick comment here. In looking at that average passing score, that's not that far away from GED with honors.
You know, it really isn't. That's true.
We're talking about 12 points. And for a student who is looking to go on to higher ed, or maybe they're going to go to the tech center and take a certificate program or something, you know, it might be worth their while when you consider this average passing score to spend a little bit more time and maybe in the classroom take a look at those performance levels and look at what the difference is between level 2 and 3 and see if there's a way that we can increase that student score so we can get those average passing scores even higher.
You know, that really is a true statement, and looking at those PLDs as we've talked about in social studies and in RLA and in math, sometimes it doesn't take a whole lot more to get them to that 170. And I'd really like to see our percentages grow in that with honors, even though I know that in most of the areas they're about 3 to 6% of all those who pass the test are in that area. Great news for us, but it would be great to have it higher too. So PLD should be really a common thing to all of us in the classroom because those are the performance level descriptors that Susan spoke of. And they really do help us to see what are the skills that students need to be pre-GED ready, GED ready, and then of course GED with honors ready. So having said that, just for everyone out there in the audience, please notice we're going through today's webinar. If you have questions, you do have a question box. Please ask away because we want to make sure that we do meet your needs as we go through this. So, Susan, let's take a look at the challenges in science, just like we did the challenges of social studies last time.
Well, you know, it comes back again, and, you know, this was really evident within social studies that it comes back to those practices. You know, we can't make a determination because, I mean, there's such a broad range of information in science, just like there was in social studies, about exactly what that question is going to be about. You know, is it going to be about energy? Is it going to be about health? I mean, we can't always know those things. But what we can do is we can focus a lot of attention into those science practices and through those help students kind of learn those skills that will help them learn other things. So as we look here on this particular slide, you can see that as they went through and took a look at the most missed items, look where it's falling within the science practices. Evaluating conclusions, but it's got that little phrase at the end, with evidence. Can I use the evidence that's there in order to make a determination and then draw that conclusion? Can I work with findings? Meaning, can I go in and can I look at that information that's there and be able to analyze that information? Can I express scientific information? Because, hey, Bonnie, remember we got 2 short answers here, and that could make a big difference in getting those students from that 158 on up closer to that 170 if they could be able to express that information in writing. And then I think the one that kind of worries me the most is about scientific theories, because our students just don't have a lot of background that they can use with that. So again, you know, we have to focus in on these practices because we can't just figure out, well, it's going to be this question and this topic and this content. What we have to do is really be looking at that overarching, those practices to see how things go. So let's take a look at one of the first ones here, which it says that they have to pull specific evidence from a written source. Well, didn't we have to do that same thing in social studies and that same thing in reasoning through language arts? I think we did, because no matter what, our students are having to find evidence and then use it in some way. Now, whether it's supporting a finding or being able to support a conclusion. So, Bonnie, do we have any questions that go along with this?
Well, you know, one of the questions that we have is how many points does a student get for answering those short answer in science? And the answer to that is each short answer can equate to up to 3 points or 3 scale points. So I always look at it as it's kind of like 3 separate questions, that kind of weighting. And so in science, it's up to 6 points for the 2 together. Pretty hefty, and something that we want to make sure that we do have students answer those questions, and we'll talk more about it a little bit later in the workshop as to what do students have to do to get those 3 points.
Okay, so let's take a look at a question that deals with this thing of having to find evidence. Because remember, you know, a lot of this test is still multiple choice. So I'm not necessarily having to write to use evidence. In this particular case, if we look at it, we can see that, and again, this is from the sampler itself or from the free practice test. What do they have to do? Which excerpt from the text supports this inference? That's exactly what they're being asked to do. So they're reading these 2 pages. You notice there are 2 tabs up there. And then they have to make a decision of which one supports the inference itself. So again, our students are going to have to use those, and we talked about this in social studies, those close reading skills where they're really looking at very precise details. That's what our students, you know, they're kind of doing a little skim scan thing. It's not going to work. They have to have something beyond that.
And Susan, when I look at this question, the setup says, you know, they have difficulty hearing predatory sounds. Which excerpt supports this inference? I don't see anywhere it says have difficulty hearing, because the answer that's supposedly correct is did not avoid the sounds. Is that an example of an inference I needed to make?
Well, that's just it. It's not giving us, again, this is part of why this test is challenging for students, because those answers aren't going to be just laid out. The answer is, and there it is. Instead, you have to be able to look at what it's saying to you and do the thing that for most of our students is one of the hardest, and that's to infer that if they're not avoiding those sounds, then maybe they're not hearing those sounds. So again, think about what that student is having to do in the close reading of this.
When I look at this one, and again it says poll specific evidence, sometimes, as Susan told you, it could be in a multiple choice or technology enhanced item, but sometimes students are going to have to show that skill and write. And this would be an example of that, where the question is to explain how something occurs and then to include multiple pieces of evidence from the text. What I would think of as a traditional short answer. But there again, if they don't explain how deforestation can disrupt the life cycle, and if they don't support their explanation with multiple pieces of evidence, they're just not going to get all 3 points. And that's another indicator of the problems that our students are having on this test. You know, scientific information and findings in words, I can see where that would work with a stimulus and a prompt where I have to write a short answer and again express some kind of findings. But how would it look if it's not a short answer? Is there some way that I would also assess that particular skill in a multiple choice, Susan?
Well, I think you can. Again, it comes back to, is there a statement that supports that? And if we take a look at this next question, basically it's asking the student to look at the information on the map and draw a conclusion. Well, you have to draw the conclusion based on the evidence that's given to you from the map itself. And so, you know, we haven't really emphasized very much the importance of still doing graphic literacy, because our students are still going to be faced with things like this, and where they're going to have to make some determinations, make an inference, draw a conclusion, but not based on some long piece of text, but on a graphic that they're going to have to use. So this is a great example of that.
So this really doesn't give me the answer right there. I have to know some information in the back of my head, so to speak, to answer this?
Well, it might be helpful, but at the same time, if I go through and I look at the legend that's included there with the continents, the plates, and the volcanoes, then I take a look at all of the different areas because I probably need to have a little geography in here so I understand what I'm looking at. But then I can take those and be able to draw that information together. So I may need some, but this is not where I'd have to be this in-depth expert on plates and volcanoes, but I really do have to be able to analyze what I'm seeing and draw
You
conclusions
know,
from there.
and the other thing is I guess I would need to know a little bit of vocabulary that a plate is not something I eat off of.
Uh, True.
Okay, okay.
That might be helpful as they're going through there so that they'd understand when those lines are drawn, oh, this is a plate boundary line, or this is the equator, or this is different things. So having some vocabulary would be very helpful as you're
The
moving
big
through.
ideas.
Mm-hmm.
And for those of you who are wondering, this again came off of the item sampler. And if you're questioning what the correct answer is, it's C. So onward and upward. Let's take a look. There's another area that GED testing service has told us that students are having difficulty with, and that is the understanding and application of scientific models, theories, and processes. Boy, that sounds real hairy, doesn't it?
Well, actually it does when you consider that that's not something we've been working with. What we've been focusing on in the past is just being able to read information and respond from there. But having this understanding about a theory and then setting up an experiment and then observing what's happened and then knowing that, oh, that didn't work the way I thought it should, and making a change, that's something that in our programs we really haven't spent time working on.
Okay, that sounds like it really should always be a short answer, because I know one of the short answers deals with experimental design.
Oh, but
I don't think it has to, does it?
No, I don't think it has to. Because in this particular one, they're going to have to take, now look here, we've got another graph. We've also got the narrative, the text itself, the passage on the left, and it's really asking them to analyze key issues and assumptions from a scientific model. So you wouldn't have to have this as something that I'm going to write a short answer. I could be asked a series of questions that go along with this.
Okay, so this could be a question.
Mm-hmm.
While the two age measurements agree for more recent dates, they often do not agree for samples dating back more than 3,000 years. Scientists attribute most of this deviation to changes in carbon -14 production. Okay. Which statement correctly analyzes the observed deviation? Boy, there's some science words there, like deviation, magnetic field. Do I really need to know a whole lot about carbon -14, whatever that is?
They have to, in this one, actually carbon-14, it very clearly explains in the narrative what that is. And it's just a radioisotope, a radioactive isotope. But what they are going to have to do then is take a look at what information they've gained from the narrative on the left side, but they're going to have to put it with the graph to be able to determine which one of those statements is correct. So a little bit more complicated. You know, I remember some questions before that we've had in dealing with things like this, and back in the 2002 test even, where, you know, if it did this, it was this, if it did that, it was that. I mean, students had to do some of these things, but this is just much more complex. But again, it's still a multiple choice question.
You know, we have a question out there since we've been talking a little bit about vocabulary. Aaron says, has anybody developed a list of vocabulary words for science? And I have to say, not specifically for this test, but we have some resources out there that can help us with the big ideas of science, and one that comes to my mind is the Reader's Book of Lists. And with that particular series, there was also a science book that gives us some of those big ideas or vocabulary of science. So I would think both of those would be helpful.
Yeah, actually, if you take a look at the Reading Teacher's Book of Lists, and you can get it through Amazon, you can get a used copy. You don't have to have the most recent edition, but even if you do, it's not that expensive. But it does break down, and it has social studies and science vocabulary that's included in there. So that's important, but just like with this, so much of what those more, quote, technical terms are, they've actually been explained if the student reads closely. It's about being able to understand what that text is giving us and understanding some of those other words. And you know, the word deviation is not just a word for science. I mean, so there's some of those words out there too. Remember, Bonnie, we've used the academic word list.
That's a great resource for those kinds of words.
Yeah, that's a really good one, because those are the words that could show up in any content area. So our students, if they have those, are going to be a jump ahead, even if they don't have every bit of the technical language of science itself.
That sounds like a good idea. And I think the other thing I would do is look through those PLDs and assessment targets from GED Testing Service and take a look at those big ideas and say, aha, here's some words that I need to make sure my students know.
All right, Bonnie, so we took a look at some of these questions and where some problems are popping up. You got any good strategies out there for us to work with?
Oh, I think we could find just a few that seem to work pretty well. And many of them don't take an Einstein to implement. How does that sound?
That sounds pretty good, actually, because you got to keep in mind that we're trying to do all this while still making sure that we're hitting the math and the integrated reading and writing. So whatever we can do that can kind of cross boundaries, you know, go across content areas, so
Very
much the better.
definitely. Yeah. Now, as we go forward into some of the slides, we'll back and forth a little bit for you between that and the guide that we've provided. Please realize that everything that you're getting from the web today, from this webinar, you can download and use in your classroom, or as we look at some of these strategies and materials to go along with them, you may say, I really like this graphic organizer, or I like that, but I'd like to tweak it a little bit. Please do so, because there again, the best strategies are those that we make our own and then work with our students. So, you know, since we're really talking evidence, 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 to me, one of the best strategies that we can teach, and it does cross all content areas as well as real world, is we need to teach students how to analyze those texts for what we call claims and evidence. Both that evidence which is right there and that evidence that students need to infer. And then making sure that in our science programs, we have our students answer what we call text-dependent questions. It's not enough for us just to ask students how they feel or what they think, but rather, can they read the nonfiction text and answer questions about it by finding the answer there. So two big areas that we need to work with. But how do we do that? What strategies work well? Well, one of the things we need to do with students is always break down what they read. All of us, when we're reading complex text, we do this. We take a look at a passage, we analyze or evaluate it, and then we show evidence that supports or disproves our conclusions. So if I'm reading something about, oh gosh, the latest diet out there, I'm going to analyze that material and see, does it make sense to me? Will it work? And then I also need to find in the readings that I do the evidence and the details that either say, yes, it does, or no, it doesn't. And so one of the things that you can use is just a simple graphic organizer. And the full organizer is on page 2 of your guide. It's nothing fancy. It just merely takes you through, and let me just quickly pull up that guide. And on the guide you'll notice that you have the most missed areas listed. But here you have just a small graphic organizer. Very simple, but getting students to the heart of things. Having them look at certain passages, analyze those passages, and then just detailing the evidence. In fact, if students could do this, they would not only do much better on those multiple choice or technology enhanced items, this is the beginning for writing short answers. So this would be one type of graphic organizer that you could use in the classroom to get students thinking. But we can go the next step, and on the next page of the guide are just some basic questions to ask. And so it gets students started that if they're going to provide evidence, what are some lead-ins that they can use? Students would say, what do you want me to write? How do you want me to write it? Well, just like thesis frames we've provided in past workshops in RLA, this is basically your thesis frames, only it's your textual evidence frames. Sometimes that's all it takes so that students know how to, quote, write the evidence. So a couple things that work quite well. The other thing is that as we are working with students on finding the evidence in the classroom, we need to be able to, quote, ask the questions. And let me click pull to an example of that. Asking questions, sometimes it's just a matter of in the classroom we're not sure what to ask or how to ask it. And again, this particular page will give you a number of resources that provide that. So let's head back to the PowerPoint for a moment. Sentence starters we looked at, and again, a great way for citing textual evidence along with just us asking the right questions when we have students look for evidence. I've been working with one of my grandsons, and the first thing it seems like he has to do anytime he reads or writes paper is to find the key ideas and then to identify the evidence that supports those key ideas. And so it's starting very early in our K through 12 system, and so hopefully as we go forward with college career readiness standards and of course getting our students to do better and better on the new GED test, we will have students who know here's the key ideas or central ideas and here's the evidence that supports it. Another great strategy is one that Susan and I have used not only in the classroom but in trainings forever, is a questioning strategy called QAR. And it goes back to, Susan, I think you told me before that sometimes the answers aren't right there in the text.
Well, see, that's the thing, and I guess the reason why I like QAR the best, because it really is, for those of you who aren't aware of the strategy, it's called question-answer relationships. And so what we have to do when we're working with this, and it doesn't matter whether, go back to, if we were to go back to that question that had all that stuff about, radioactive isotopes and you had to go to the graph and you had to make decisions from there. It can be an image or it could, be something that's in the text itself, but sometimes answers are right there, but sometimes they're not. I have to think, I have to search through the different information, and sometimes I have to actually bring a little bit to the table myself. So what do I know and how can I make those decisions? How can I determine whether something is accurate or it's not. We're not always fortunate enough, and that's life, to be able to just go out there and boom, right there's the answer. Most of the time we're doing a combination of things, which brings it over to, in my head, I'm having to work through and make those inferences and draw those conclusions. So it's a great strategy to use no matter what you're using, whatever the student is reading, whether it's science or social studies, or they're doing some other nonfiction text or even fiction. The process will work across the board.
Okay, so QAR, and in your guide you do have a page that provides you with that introduction if you've never used QAR before. The bottom line is, as Susan said, we don't always get answers right there. So what QAR assists us in doing in the classroom is really making students a little more comfortable that sometimes they do have to reach inside their head to figure out what the author is saying or to add some of that background knowledge.
Yeah, one of the biggest issues that we have out there, and Bonnie's included the text-dependent questions for science, is really the fact that our students are just not reading closely. And a part of that is our own fault, because we often ask questions that a student could give an opinion, or maybe, you know, they just don't have to read the text at all. And so we have to be really cautious as we're working with science to say, you know, whatever I'm having students read, that I go back and I develop text-dependent questions that require that student to dig into that text in order to understand and to be able to find those answers. It's something that it's something we're going to have to work on across the board, and we're going to have to be really cautious with our materials that we use to make sure they're doing the same thing, and that students can't get away with just giving some kind of interesting question or answer to a question because they really didn't have to read the text in the first place.
Ah, that's so true. And I think Susan got ahead of us a little bit with this because she talked about vocabulary, and is there a vocabulary list out there? And although we said no, there is not, we do know there are some excellent vocabulary strategies. And it really doesn't matter on what types of strategies we use, as long as they are strategies that teach students how to apply the vocabulary so that those words become their own. We all know that unless we're excellent memorizers, that 10 words on Monday, test on Friday with nothing but definitions just doesn't help us own words. Susan last week in the social studies talked about a strategy called a narrative chain, where you take words in science and you have students create sentences that use those words in context. Well, there are a lot of other strategies to assist. Narrative chains, absolutely marvelous, both for science and social studies. But you can also do some big concepts of science by having students do something like some of these strategies here, where they use the word or concept and they may define it, but they define it in their own words. They may draw a picture because that's what works well. They draw science using it in context, and they provide an example of where that term or that concept is used. When people say, well, what do they need to memorize for the science? It's not like they have to, quote, memorize Newton's laws of motion. But do they understand that if they're given a law, what would be an example? What would be an application? That indeed would provide the big ideas of concept or of science. Or if there's a vocabulary word, like a couple that we saw previously. Oh gosh, even the word variable. I know I use variable in math all the time, but is there a science area that I use the word variable as well? And can I give not only a definition, but an example of how I would use that term in science? So strategies for science, definitely some vocabulary out there will not only assist our students in being better learners and having a better vocabulary, but also understanding the big ideas of science. Because bottom line is that learning new words is cumulative. And probably one of the most difficult things for me sometimes in the classroom was to remember that as I was teaching those new words, I needed to do that science talk with my students, whether it be brainstorming or how it was used. So there again, productive vocabulary has to extend beyond word definitions. So as you look at these ideas, think of how do you teach vocabulary in your classroom? Do you use all of these different resources for doing it? And if so, fantastic. This looks real hairy, Susan.
Well, it does look a little hairy when you put it all together, but at the same time, it doesn't have to be. It can be something that's very basic, moving through. But what we want our students to be able to do is to, this is almost like problem solving in math. You define your problem. Well, we do that in math. And then you kind of figure out, okay, I'm going to use this strategy to solve that math problem. Well, in science, we're proposing a hypothesis. And then if you're going to solve a problem in math, you got to make sure you got all your numbers together. Well, in science, we're gathering evidence so we can test it. And just like in math, although many times our students don't want to do this, they get an answer and then they want us to check it, but they need to be doing that themselves. So here we've tested the hypothesis, and then we can either reject it, say, whoops, that wasn't true, or wow, that worked. That was what we had. And so now you've got a theory. I think what happens with our students is, we say this scientific design or experimental design, and then students go, well, I'm not a scientist, I can't do that. Well, yes, they can, and they actually do these things in real life. They just don't think of it that same way.
Would that be kind of similar to if I decided that there was something I really love to eat, and I get like 3 or 4 different name products of that with different product names, and I would have to determine which one I like best because it suits my taste buds? Would that be a scientific method?
Sure. Why not? I mean, you could go through and do any number of different things. And I think that's where students need the opportunity to see how this works in real life, and not just something that, oh, that's in this big, thick science book. But, I mean, everything we do is connected to science in some way. We just need to be able to bridge that gap for students so that they understand that especially science can have such a positive impact on them with everything they do in real life. So, we need to take the fear out of it, and that it's not this big bad thing that's too hard for them to learn.
Well, is there any reason I really need to know about the scientific method?
Well, let's think about it. Do you, Bonnie, ever use the scientific method?
Actually, I probably do, don't I?
Probably so.
Plus the fact I do know that there are 2 short answers, and one does require that I do a scientific investigation.
Well, that's a good enough reason, at least for this test. But
Oh, okay.
We also need students to understand that this is not just about, oh, let me do this for this test, and then I don't ever think about it again. Yes, we do have a short answer that we hope our students are going to be able to respond to and be able to earn points from it. But at the same time, we want that information to go beyond just the day they take the test, and to be something that they can come back and use as they go forward. But yeah, I mean, we do have 2 different types of short answers. We have one which is just that typical you know, you read the text and you're going to look at the relationships and then you're going to respond to a question. And then another one where they're going to have to actually set up a scientific investigation and then describe it. But, you know, the thing that everybody has to keep in mind is that, you know, with short answers, each one of them has its own scoring rubric and its scoring tool. And for those of you out there who have not yet pulled down the scoring rubrics and the scoring tools for science, it's well worth the time to spend a little time looking at it and investigating what the expectations are for our students in the classroom.
And although we want you to do that, we're going to take just a quick look at a couple examples, but just a few strategies too as we look at scientific design, because we do know that students, in order to be successful on this test and hopefully in life, they need to know how to design the investigation and have those basics. How is the experiment set up? And when they do this, there are a few things that they need to have in their answers. The key elements in that particular short answer that GDTS would be looking for is, first of all, is the experimental design well designed and complete? In fact, one of our fellow instructors said, could I replicate it? As I sit looking at that scientific design and how my students wrote it up, could I, by reading it, replicate it? The other thing they look for in their answers is there a method provided for collecting data? Is it telling you as you're doing your experiment how you're going to collect data and what data you're going to collect? And finally, does the student or the test taker explain the criteria that he or she uses to evaluate whether the hypothesis is correct or not? If students provide all three elements into their answer, they should get all 3 points. Now again, all three elements have to be developed well, but there again, those are the basics. So let's take a look at what an answer would look like having those 3 key elements. And this should look real familiar because it comes out of that short answer that talks about this farmer who is setting up, or he's hypothesizing of what method is going to be the very best method to use so that he doesn't lose as much topsoil. So if I take a look at this, it says the farmer would have to set up 3 experiments. The first would be a year's worth of traditional farming methods, plowing and no cover crops, on a 5 by 5 acre of land. Now you may say, 5 by 5? Did it have to be 5 by 5? Could it have been 6 by 6 or 10 by 10? And the answer is, doesn't really matter. The student has very much described how he or she's setting up the experiment. That's what GED testing service is looking for. Now the second element was whether there was a data collection method. And this particular test taker has said he would have to measure the topsoil every month for a year and record it in a table. So yes, this particular test taker has told me how data is going to be collected. And then the third key element that I need to see in the written response is that evaluation. How do I determine whether the hypothesis is going to be correct or not? And here again, this particular test taker says at the end of the year, this is what the farmer needs to do to determine if his hypothesis is correct. Now you're going to notice there's a couple typos. No, Susan and I did not type this and forget to put it through spell check. This is how the test taker had written his or her response. And because I can read it just fine, I know that METHID is just a little typo. It's actually method, and I know that that's the word against. That doesn't count against anything. But this would be an example of a short answer that would get all 3 points because the student has described the experiment clearly, has provided a clear data collection system, and has given an explanation of how he or she would determine whether the hypothesis was clear or not. So that's what GDTS is looking for in experimental design. And it's something that each of us can replicate in the classroom dependent upon what type of an experiment we do. Again, it's not about length. It is definitely about completeness. Susan, anything you'd like to say on this particular one?
Well, I still think, our biggest concern is that students are thinking, and maybe we're even thinking in the classroom, that these have to be really long and involved, and they're not.
True. No.
We have some that score quite well, and they're just a few sentences long, but they have the elements there. That's the main thing, that students understand what that question wants them to provide, and that they provide those three basics. And as we go forward and you see things over the years, as things change, we may have a greater expectation in terms of length. But right now, we're just getting started with our students, so don't let these kinds of things cause any real concern, because it's about answering the question and answering it completely.
So, having said that, on short answers, any questions from the field? Everybody's been awfully quiet out there today. Well, if not, then we'll head on. One of the things that Susan and I have seen as we've looked at this new science test, it's not so much about just regurgitating information and being able to just recall these facts, but rather how can we use science? How does it work that way? And so as we're looking at strategies, I know many of us have seen this. It's all about what we call the 5 E's. And when we're developing lessons, it is important that we identify those big ideas that we want to teach. And as we identify those big ideas, that we build our lesson plans around the 5 E's. First of all, we all know how important it is to engage our students. If we don't engage them, we've lost them. But also in science, it's equally important that we have them explore scientific ideas and that they're able to explain back those ideas or that concept and then apply it in different situations. And finally, letting us know that they really understand what has been taught by us providing time for review and reflection. Again, all about the big ideas in science and doing the 5 E's. In fact, it doesn't sound a whole lot different to me than the way we teach all big ideas, be it science, social studies, math, etc. We want to engage students. We want them to explore so that they can create their own understanding. We need that explanation and elaboration. And finally, of course, we need the evaluative step. And science is a neat place to do this because everything about science is so interesting as far as just kind of clicking our students' scientific curiosity. Now, Susan and I know that most of us do not have a science lab, but it doesn't mean that we can't do hands-on activities. And we're going to show you a few at the end of this webinar because many of you are already implementing hands-on activities. In fact, last year, one of our fellow instructors did a grab and go that showed a great experiment that students not only had fun with, but required very little from each of us as instructors to get it implemented. So, science lessons, 5 E's. Engage our students, explore the meaning of concepts through as much as we can hands-on because students need to see science. Explain how it's part of our real-world situations because we always remember things better. And there's a second E in that one called evidence. And since we know that textual evidence is a problem, we need to make sure that when we explain things, when we have students read about things, that they can identify the evidence that supports that explanation. There again, we would call this transference, but it's elaboration under the 5 E's. Can they see where these things occur in different contexts? Because science doesn't just always, it doesn't occur always in a lab. And finally, again, we need some time for review and reflection with students to make sure that they understand it all. So, Dave Coleman, who is co-author of the English Language Arts, gosh, I don't think of science there, but he said to increase science reading and writing skills, each student needs to read like a detective and write like an investigative reporter. You know, Susan, this sounds real familiar to something that you covered last week. I think you called it reading like a historian. Can I read like a scientist?
Well, and I mean, we just have to tweak some things. I mean, you know, the bottom line is that we need to be more critical readers. And, you know, if we're going to do that, we can work through a number of different things to help our students gain those skills, because they're absolutely essential as we work through. And I think, I believe, Bonnie, you have a chart in here somewhere.
Yes, I do, and I'm going to make everybody dizzy as I'm going to find it in just a moment, because there it is.
Yeah, because as you look at it, look at the thing. It's the same for working with a primary source and science as what we did, except that reading number 4, we said it's read like a scientist, where we're connecting, we're asking questions, but look at those questions. Those questions are still the same. You know, what is the author's perspective? This scientist in his writing, what is he bringing forth? What is he saying? How does the way he feels, and he's expressing things, his perspective or her perspective, how does that impact that argument that's being laid out, the claim that's being made? Also looking at it from a standpoint of, do you have other questions after you read it? Is there something else you want to know as a result of it? But again, it comes back to that closer reading that we really haven't focused on that much in our different areas.
Okay, so I can read like a scientist. But a couple other things to just kind of assist you as you're working with students, because we all know that sometimes graphic organizers work real well. Well, as I read nonfiction text in science, I can use something similar to this graphic organizer that you have in your workbooks or your guides on pages 19 and 20. And again, it just helps students to outline the things that we know they need to be looking for to be more effective readers. So as they're reading nonfiction text, be it social studies, science, or something for RLA, can they identify the central or main idea? Can they then summarize that in their own words? And there we have that textual evidence, provide those supporting details. But I like what this graphic organizer does with this next question. How does this connect to previous learning? Can I connect it to something I know? You know, Susan, this would be a great question for that social studies extended response where they have to provide a little bit of their background knowledge to the answer.
Yeah, it would.
And then, of course, how's that text organized? Is it chronological? What's the format of it? And how does that organization help me understand it better? If it's something that is a step-by-step process and I understand that, wow. Or if it's a cause and effect, great. Again, text organization or text structure, really, really important as we read. And then again, what's the author's purpose? Just a simple graphic organizer that can help you help your students become more effective readers in science. So, having said that, let's click back to the PowerPoint and just take a quick look as we look at some strategies. And I know we have a few questions and a few comments out there, Susan. So,
Well, let's just talk about it for a second. You know, I mean, the main thing here with strategies, and you have quite a bit on the workbook, and so we do hope you'll go back and really spend some time with that, because we've also included some websites for you. But since we only have a few more minutes left in this webinar, keep this in mind. We have to be, Bonnie brought it up earlier about we got to engage, and that means we've got to have time for students to do certain types of things. We have to teach explicitly how these things relate to science, and we've got to do some modeling as well. But, you know, take advantage of all the wealth of information that is out there, whether it's videos or pictures or graphics, other things that you can do, but it still comes back to how can we engage our students. The more they're engaged, the better that they're going to do as we go through. So, Bonnie, what are some of those questions that we've got out there now?
Well, one of the questions comes back to the short answer, and it says, are they more heavily weighted? And Pearl, each short answer is not weighted, but it does get 3 points, so 3 scale score points. But as I score it as a teacher, I'm going to give it a 3, a 2, a 1, or a 0. I don't multiply that by anything. There again, it's just that part of the scoring. So that differentiates it from RLA and social studies, where you know you need to multiply those answers, those extended responses in each trait by 2. So again, simplistically, each short answer would really equate to 3 questions on the test that are technology enhanced. And then the other, actually it's not a question, but it's a comment, and it's one of those things that we may want to post, but Karen Miller found a site, and it is from a publishing company, but what it's done is it has put together a list of science words, you know, including things like heterogeneous, heterozygous, I was going to put the genus there, and that list was gotten from practice tests, etc. So there again, that may be a great resource for us to at least post on the Florida IPDay website. So Karen, thank you. But that's it for right now. So as we finish up, Susan, let's ask for some questions, because I know that we are kind of drawing towards the end. So, just for your information, you saw earlier in this webcast the Florida IPDay website, and where you can go back to get resources. But one of the things in the guide that you should have downloaded, or will after this webinar is over, is a sample lesson plan, which is also posted on Florida IPDay. It's a lesson plan that will take you through experimental design step by step. But the other thing when you go on to Florida IPDay is under the grab and goes, there is a great grab and go that deals with a scientific experiment as well. So be aware of those things. And last but not least, just like Susan had provided for us in social studies, we've provided in your guide 2 pages of some of our favorite websites for science. Everything from the Annenberg Learner to Exploratorium to Discovery Channel to Newton's Apple, all kinds of things that are out there for our use in the science classroom that are free and really, really well done. So, having said that, questions? Okay, it looks like we have just a couple questions out here, Susan, so give me just a moment and make sure we cover them all. And while I'm doing that, as you have questions, if you will please key them in or type them in for us. Okay, back to writing samples. We've got a question, how much do the writing samples count in RLA and social studies?
Okay, so let's go back. In social studies, a student can earn up to 8 points. The total number of points that they actually earn is 4. It has a weighted factor of 2, so they can earn up to 8 points in social studies. And in reasoning through language arts, they can earn up to 12 points. So the maximum number of points that they can earn on that is 6. That's multiplied by 2. And that's how you get the 12. So our students really need to maximize those points as they're going through, and the way they're going to do that is to do more reading and do more writing and focus on the evidence.
Another thing is Karen comments, and she's so correct, that sometimes the extended response question or short answers offer clues to what can be written in the answer. And Karen, you're so correct. We need to teach students to identify the clues in the prompts and the reading samples so that they understand what they should be looking for. Great comment, great teaching strategy. PLDs from Cindy. PLDs are found on the GED Testing Service website. If you go under for educators, it's got right there the list of the performance level descriptors for all 4 of the subtests. Okay, we have a question of, can a student get a 0 score for short answer response in science?
Yes, they can. And there is if the student quote earns a 0, basically they have either not responded to what the question is, or it is so insufficient it lacks those elements. Remember that students can get a 3, which is the top score, and that means that they really have done a good job in responding and including all those elements, all the way down to a 0. We can't say it enough. Go out to the GED Testing Service website and download the scoring tools and the scoring rubrics for science. You really need to take a look at those because each one is different. And so that's your first step, and it won't take you long to go through and read those and get an understanding of what the expectations are.
And Suzanne, your question is, am I correct in telling students that they're able to highlight text on the screen while testing? And yes, they can, both on the GED Ready and on the official test. They do have highlighting tools, and when they go through the tutorial, they're shown how those work. And the tutorial, of course, has to be done ahead of the test. And the other thing they can do is they can enlarge the font as they read through. And I think the last question I have right now, Susan, is, are the writing samples computer scored?
Yes. The writing samples for the official tests are all computer scored. They call it an electronic scoring engine. But on GED Ready, that is something that you as an instructor would need to go back and score those, because they do not do electronic scoring on GED Ready, but on the official test, yes.
And at this point, Susan, I think that that is pretty much what we have for today. And so I'd like to thank everybody for being with us, and just please note that all the materials that we have for this webinar and last week's as well, they do not require permission for you to copy them for educational purposes. Again, they can be reproduced in their entirety. Attribution, again, should always be given to our home website of Florida IPDA. But again, everything is there for you to use with your students, to modify as you need to make sure that you meet their needs. So on behalf of Susan and me, we'd like to thank you very much for being with us this afternoon. And if we do not, quote, see any of you before the end of this month, have a great Thanksgiving. Susan?
Have a great Thanksgiving. Have a great rest of the week. And we'll be in touch soon.